There has been evidence that the concentrations of these acidic oxides have significantly increased, especially in the last 50 years. This is mainly due to rapid industrialization, increased demand for oil and other fossil fuels, as well as the increasing populations all over the world. The evidence that is observed, which indicates an increased atmospheric concentration of these oxides, are mainly from the monitoring of pH in soil, forests, degradation of buildings, aquatic life, which are all affected by acid rain. There is also evidence from the increased acidity of rivers and lakes, as well as the comparisons of atmospheric concentrations of sulfur dioxide and oxides of nitrogen in industrialized areas and non-industrialized areas. The analysis of the changes in the atmospheric concentrations are usually conducted by environmental protection authorities. From the analysis of the Antarctic ice core samples by the CSIRO and the Australian Antarctica Division, you can see that the concentration of nitrous oxide has increased by about 15% over the last 115 years. And also that there has been an increase of over 25% in atmospheric carbon dioxide levels over the last 200 years.
This was observed from the detection of higher atmospheric concentrations of sulfur dioxide and the oxides of nitrogen in industrialized areas, particularly in Europe, where there has been an increase of acidity in lakes and rivers around the areas. There has also been damage to forests, buildings, and aquatic life around industrialized areas, which can be due to the formation of acid rain by the increased concentration of these acidic oxides. The evidence which indicate that the concentrations of atmospheric oxides have increased are difficult to obtain since they are present in very low concentrations. This is also because of the lack of accurate data before the 1950s, since the chemical instruments able to measure very small concentrations like those for sulfur dioxide were available only in the 1970s. The validity of measurements of their concentrations can also be questioned since sulfur dioxide and nitrogen dioxide are both soluble in water. On the other hand, carbonates are insoluble. This makes it easier to obtain evidence for the increases of atmospheric carbon dioxide, especially since carbon dioxide concentrations are much larger than the concentrations of sulfur dioxide and the oxides of nitrogen. There are also other ways to measure past carbon dioxide concentrations, including isotope ratio measurements using mass spectrometers on shells and corals of different ages, allowing for more accurate comparisons.
Therefore, even though we do not have accurate measurements of the changes in atmospheric concentrations of sulfur dioxide and oxides of nitrogen taken over a long period of time, there is enough indirect evidence to indicate that significant increases of concentrations of these acidic oxides have taken place, especially since the Industrial Revolution. In response to the increase of atmospheric pollution, several regulations and policies were introduced to control the emissions of these acidic oxides, which have caused an improvement in the air quality. These include introduction of emission controls in motor cars, reducing the amount of coal being burnt through production of energy-efficient appliances, reducing reliance on fossil fuels, reducing acidic emissions from smoke stacks, ensuring exhaust from motor vehicles pass a catalytic converter, allowing to convert back to harmless nitrogen gas, and the introduction of operation procedures to reduce emissions, including the trapping of sulfur dioxide.